Hi guys. So far you have worked on different ways of creating lines given different parameters or different stipulations. Um, the final way is the one that will most interest some of you because you're very keen on asking when in life you'll use this. The only time usually you will use this, the graphs won't be perfect. They're not always, when you're graphing real world information, it's not perfect cut and dry information, and there are points all over the place. For example, if you're analyzing gas prices throughout history, obviously they're going to fluctuate, and you're going to have time is your independent variable, dependent is the gas prices, and gas prices are going to be the same sometimes for different years, but it's going to vary, and you're going to have just what looks like a bunch of plots and points all over one graph. But what ends up being similar in all these real world examples is that you have positive values. Very rarely are you graphing negative values. There are examples of negative values. When you graph temperature, you can have negative, and when you graph sea level, you can have negative. There are real world negative examples, but a lot of times you're always looking at two positive coordinates when graphing real world examples. So it's usually in the first quadrant. So that's one thing that's going to be similar. But last year you looked at scatter plots, and this year you're going to look at scatter plots again, except you're going to have to come up with an equation for these scatter plots. And the equation's not going to be the same as everybody's isn't going to be the same. It's going to be based on what 2 points you have personally picked to analyze. We're going to look at a set of information and see how it relates. So, last year when we did this, we did arm span and your height. And we noticed that the taller the person got, obviously the longer their arm span is. That is a positive correlation. And we'll discuss those in a second, but I'm going to give you an example of a scatter plot first. So, an example of a scatter plot I am going to tell you is oh, that's beautiful. You have to bear with me. I'm using my mouse as opposed to the actual whiteboard. So, it is what it is. Alright, so you're going to have x and y, and you're going to have to decide what's the independent and what's the dependent variable. So your height is your independent. So we have height. And I don't want to spell out height all by myself with my finger. Well, I did anyways, but there we go. Height. There's height. It's my x. That looks like a y. Arm span, we're going to just call that AS. That is my Y. Alright, so we just did this recently with 6th grade. There were 2 people that were spot on the same. So 61 and 61. And then somebody was 60.5. And 60.5. 58 and 62. 55 and 57. And And then, let's see, somebody was 59 and 58. And there are more people, but I'm not going to plot them all. Anyways, then we discussed how, if you noticed, most of them are, there was one small, and one really tall. But if you notice, they're all within a certain amount. So we have a break. We're not going to graph 0 to 50. We don't need to. It's unnecessary. So we're going to have a break here. And then we're going to have a break here. And to do a break, you do a zigzag on the axis. This is the origin. You don't have to do it on both. In this case, I am going to do it on both because both of the x and the y aren't starting right at 0. So here, I'm going to start at 55 on both because they both start not too bad. So we're going to start at 55. And then we're going to go up. We're going to go up by ones. 56, 57, 58, 59, 60, 61, and that's great. And then, actually, 62, and I'm just going to copy and paste this. So if you haven't already, I sure hope you've already started making this, but if you haven't, go ahead, because here is the tricky part. Not the plotting the points. Good grief, not the plotting of the points. I hope not, at least. You're going to go ahead and plot the points. Okay, so if you noticed, there's a couple things missing. First, there's if it's real world information, it needs to have labels. So this has to have a label. So the x has to have a label, which we know is height. And the y has to have a label, which is arm span. Okay. As height increases, so as height increases, that's going this way. As height increases, arm span is also increasing. It's going upwards. So just like in slope, you're reading from left to right. It's going upwards from left to right. Ironically, just like slope, it's going up from left to right. This is a positive correlation. Okay, and then we could use a line to help us estimate a person's arm span given a specific height. So say we have this random giant who we know what their height is, but we can't get close enough to measure their arm span, we could, given their measurements, find their arm span out. So what we do is we make what's called a line of best fit or line of regression by making a line that goes through as many points as possible. But if it doesn't go through, if you can't get it to go through many points, it has to be so that it's balancing out the points. So an equal number above as there are below. So when I go to make this line, there needs to be an equal number of points above as there are below. And if you notice, it's going through, almost going through 3 points. With one above and one below. Now, after I've done that, I need to mark 2 points, whether they're 2 points specifically on the line that you were given, so 2 of these points, or you personally can create them and make them on that line. So, here is a point, and we're going to use this as a point, and we're going to make them perfect. Like this one was and this one is 161. No, that one was 60.5, 60.5. Alright, so we're saying that those are the 2 points on it, and I marked them so that I know which ones you've chosen. And then all I'm doing is creating a line from those 2 points. And we're going to make it a line in slope-intercept form. So, if it's in slope-intercept form, I need a slope and I need a y-intercept. So, the first thing I need to find is the slope. So my slope is rise over run, and instead of counting, I'm going to take my y's and subtract them over my x's and subtract them. So I'm going to take 60.5 minus 57, and I'm going to get 2.5, and I'm going to take 50, since I chose 57 first, I have to choose 55 first. I did not choose 57 first, I chose 60.5 first, so I have to choose 60.5 first, minus 55, and I get 4.5. So I have 2.5 over 4.5, so I can literally take, in my calculator, 2.5 divided by 4.5, and yours, if you push second or math fraction, it will change it to a fraction for you, but that's just 5/9. So I know that my slope is equal to 5/9. Alright, so my slope is 5/9. Now, I have 2 points to choose from, so I'm just going to pick the 60.5. So I have y minus 60.5 equals, let's choose the one that we don't have decimals with, or fractions with. So y minus 57 equals 5/9 times x minus 55. And then simplify that. Add 57 to both sides and distribute the 5/9. So we're going to have y equals 5/9 x minus 55 times 5/9, and then that's negative because it's already minus, plus 57 equals 26 4/9. And there you go. So that is creating real-world examples with what we have been doing. Now, like I said, there are different types of scatter plots, but there's only 3. So just like if you're looking at slope, there are 4 different slopes. So there's a positive slope when it's going up from left to right. There's a positive correlation when the points generally look like they're going up from left to right. If the points look like they're going down from left to right, it's a negative correlation. So as the x is increasing, the y is decreasing. So there's negative slopes, so there's negative correlations. There's not a vertical line correlation, and there's not a horizontal line correlation. But there is one other type. It's called no correlation, where it's just a bunch of scattered points. So there's your 3. Positive, negative, or no correlation. And no correlation is when it has a bunch of points.